So today we're going to work on lesson 2-4. It's going to be 3 parts. In the first part, the title of the lesson is the effects of alcohol, but the first part we're going to work on has to do with pizzas. So let's look at our quote of the lesson. It says, "As long as algebra is taught in school, there will be prayer in school." Not sure what that's about, but I think it's because if people don't like prayer, there's lots of people that don't like algebra too. I don't know. So we're gonna, it says it's no secret that alcohol consumption by college students is common and that overindulgence can have many negative effects in both the short and long term. And if anything, the problem is getting more and more serious. At my school alone, 21 students were hospitalized for alcohol poisoning during one recent weekend. When someone makes a choice to drink, they're affected as long as the alcohol remains in their bloodstream. There are many theories on how to hasten the sobering up process: black coffee, ice cold showers, greasy food, drinking lots of water. The truth is that none of these have any effect whatsoever on blood alcohol concentration. You can try every mythical treatment known to man, but at the end of the day, the only thing that will bring down BAC is time. So let's just go down here to the bottom of page 171. It says a student org you're involved in is planning a year-ending pizza party to celebrate another successful year on campus. As chair of the planning committee, you've wisely worked to deal with a local pizza place to provide large pizzas at $9 each. The budget will allow at most $175 to cover the food. And of course, you'd like to know how many pizzas you can get and stay under the budget. We'll attack the problem in several different ways. Use a numerical calculation, include all details, and don't forget to write the number of pizzas you can buy. So there's lots of ways you can do this. You could do some guess and check and say 10 pizzas is equal to 9 times 10. So that would be $90, right? So if you double the pizzas, then you could double this to be $180. So not quite 20 pizzas, right? That's one way. Or you could say, I'll take my $175 and divide it by 9. And we're going to get 19.44 pizzas. But remember, this is back to similar to lesson unit 1.7. We can't just buy part of a pizza. Now, some places do let you buy per the slice, but I'm assuming they're cutting us a deal because we're buying whole pizzas. So at most, we could buy 19 pizzas. It says write an equation that represents the total cost C of ordering P pizzas. And we said that would be $9 times P pizzas. Okay, let's flip the page. So number 3 says, complete the table, then use it to estimate the number of pizzas you can buy. So we said if 0 pizzas, there will be 0 cost. 5 pizzas will be 5 times 9. So this will be 45. We said 10 pizzas cost 90. We already know that 20 pizzas cost 180. 15 pizzas at $9 each will be 135. 25 pizzas at $9 each would be 225. And 30 would be 270. So somewhere in here, we already know, just because we can only spend $175. It says use the information from the table to draw a graph with the number of pizzas on the horizontal axis and the total cost on the vertical. Make sure you label the scale on each. So we'd like to go up to 30. So I'm going to suggest if we go by ones, we'll only get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I say we go by 5s. So this will be 0. We always start at 0. So 5, 10, 15, 20, 25, 30. So we've got plenty of space. And then our cost goes all the way up to 270. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 If we need to go up to 270, that's just under 300. So I think if each of these goes by 30, then we would be at 300 up here. So 30, 60, 90, 120, 150, 180, 210, 240, 270. And we said that 30 pizzas was at 270. So I'm going to go over to 30 and up to 270. There's one. 0 was 0, 0. 5 pizzas was 45. So it's somewhere in between here. 10 pizzas was at 90. That's going to be an even dot. 20 pizzas was at 180. That's going to be this even dot right here. 25 was at 225. So somewhere in here. And 15 was at 135. So somewhere in here. I'm trying to do it because I know it's going to make a linear line. Since we want to spend at most $175, this is a good place to use an inequality. Write an inequality that can be used to find the number of pizzas you can buy for at most $175. So let's write some other words for at most. So we could say not more than, not more than, and then, but we're including, right? So the cost has to be less than or equal. Oh, wait. Oops. Pizzas. So the pizzas are $9 each and the 175. So that this cost has to be less than or equal to 175. You could also write it, you might have also written as 9 times P, or the cost has to be less than or equal to 175. Okay, because we can't go over the 175. So number 4 says, what's the slope of the line you drew in question 4? What does it represent? So we talked about how this makes a triangle. Our slope makes a triangle. So we said our slope is change in y over change in x. And you might already know what it is, but I think we should go through the points. So I'm going to pick the points 5 and 45 and 15 and 135. So my change in y is 135 minus 45 over 15 minus 5. So 135 minus 45 is 90, and 15 minus 5 is 10. So my slope is 9. And we have to remember our units were dollars. The y units are dollars, and the x units are pizzas. So $9 for every pizza. What's the y-intercept of the line? What does it represent? So the y-intercept is when we're crossing this y-axis. So it's right here is the y-intercept. And it means when we purchase 0 pizzas, it costs $0, which is fabulous. Okay, it says, nice job so far, but did we forget to mention, oops, there's a $10 delivery charge. Sorry, you'll have to rework the problem, keeping in mind that we want to know how many pizzas we can get for at most $175 at $9 each, plus a flat fee of $10 for delivery. Write an equation that describes the cost C of buying P pizzas with the delivery charge included. So our cost is we have to add $10, that's off to the side for the delivery, and then $9 for pizzas, right? Okay, so now it doesn't matter how many pizzas we buy, at 0 pizzas, we have to pay $10 for that delivery fee. So now all of these have an additional $10 for them because we have the delivery fee. So this one is going to be 55, 100, 145, 190, 235, and 270. Now, number 10 says, use the information from that table to draw a graph for the number of pizzas of the axis. I'm going to show you on Desmo so that you can see both graphs all at once, from when we didn't have a delivery fee to when we do have a delivery fee. I think that's good to see. Okay, so I'm going to go to a table here, and I'm going to put in, we had 0, 5, 10, 15, 20, 25, 30. Okay, and then originally it was 0, 45, 90, oops, 5, 180, and 270. And then we said, once we add this is going to be Y2, we're going to add in the delivery fee. So 10, 55, 100, 190. I'm going to hit my magnifying glass, and you can see the green is without the delivery fee and the purple is with the delivery fee. So it's all just really shifted up, right? And how much is it shifted up? That's a question. So let's go to page 174. It says, write and solve an inequality that can be used to find the number of pizzas you can buy with the delivery charge added. Okay, so I'm going to go back to my paper here. And so it says $175. We have our $9 for pizza plus 10, right? So this cost cannot go over. It has to be less than or equal to the 175. So we know if we take the 175 and subtract that $10 delivery fee, we'll have $165 left to spend, right? And then if we divide both sides by 9, we have 165 divided by 9. And so it says 18.33, but we have to have whole pizzas, so 18 pizzas. And the cool thing is, if we go back to a picture here for a minute, we can say, let's just go up to 175. So we can, okay. So we said we had an inequality, right? So we're looking at, I'm going to draw the line at y equal to 175. And you can see that it's right about in here. It's gonna cross. So let's go back to our paper and see how we can work this out. So 12 says, what is the slope of the line you drew and what does it represent? So the slope was $9 per pizza. What is the y-intercept of the line you drew? So the new line we drew has a y-intercept right here of 0, 10. So really that means before we purchase any pizzas, we have the delivery fee of $10, period. So 14 says, now here's the key idea. Look back at your answers in questions 8, 12, and 13. The slope was 9. The y-intercept was 0, 10. And the equation was the cost is greater than or equal to 9 e plus 10. So at the top of page 175, they give some great information about the equation, and they talk about how the slope, the value on P or X, is called our coefficient of X. And then our y-intercept is always our constant term. So this is our constant. It's something we have to pay no matter what, that delivery fee. And this is, that 9 is our slope, is called a coefficient in my equation form. And we call this form, which we brought up before, the slope-intercept form. It's right here, but I'm going to write as b plus mx. Or you can write it as y equals mx plus b, either way. So our last couple questions here says, a small business had just 12 employees when they opened their doors, but they have been adding employees at the rate of 4 per month since then. Write a linear equation that describes the number of employees in terms of the number of months after the company was founded. So I'm going to say employees, I'm going to use the letter E, and months is going to be M. So for me, I'm going to have employees, right, is equal to, it started with 12. So that sounds like that's going to be a constant. We started with that, and they're adding 4 per month. So 4 per month. 16 says, what are the slope and y-intercept of this line, and what do they tell us about the company? So the slope is the 4. So just 4 is your lesson check for this lesson. And the y-intercept is 0, 12. And it says, what do they tell us about the company? The company is growing. That's good. And then it says, use this information to draw a graph of your equation. Be sure to label and scale. So we're going to have number of months down at the bottom. And we always start at 0 and 0. We're going to decide our scaling. And this is going to be the number of employees. So 1, 2, 3. I think we can go by ones because we're just talking about months. 4, 6, 8, 10. Okay. And then employees, since we started at 12, we're going up by 4s. Maybe we could make these go by 5s. We could even go by 4s if we wanted. Sometimes it's nice to go by the slope, but we could go by 2s, 2, 4, 6, 8, 10, 12, but we wouldn't even get to the y-intercept till up here. So if we did 5s, we could do 5, 10, 15, 20, 25, 30, 35. So our y-intercept is at 0 and 12. So it's going to be between this 10 and the 15. So it's going to be right closer to the 10, right? And then it grows by 4. So at 1, we added 4. So that would be at 1 month, we added 4, which would be 16. So we're just above the 15. And then make a little table here, right? So we start with 12. At 1 month, we add 4 to get 16. After 2 months, we have 20. So at 2, we have 20. And then at 3, we have 24. So we're just under the 25. And then at 4, we add 4 more. So we're at 28. So we're just under the 30. So you can see there. So sometimes they give us a story in words, so we can tell from the story and the words what our slope and our y-intercept is. And then in the last lesson, we did it from some points. So we found from our coordinate points where we actually calculated the slope. We've learned a lot about graphing. And when you catch us back for lesson 2 for part 2, we're going to extend on these concepts. So we will see you then.